Alright, so let's just pick up where we left off and see if we can't finish up alternations here. So the thing that we decided is that we need to actually maintain state here and push this current index onto the stack so that it's available. So if I go back to MatchAlternate and during the match forward process, if I've actually matched this index, then what I want to do is just save that piece of information. So I'll say context.stack.push index. Great. So that's why I need this brace, and that's that. So when I'm matching forward, starting at the beginning, just keep trying to match one, and if I do, let's push that to the stack and then bail. If I don't match any, then we've failed. That's pretty much it. So let's go over here and see if we can't put one of these together. Public static void match alternate test 1, and it's going to look like this. So I'm going to open that guy just for reference. So var context equals new matching context on the string. Let's think what would be a good test here. Well, we'll do ABC for now. Var match char A equals new match char of A, and var, this is a little boring, equals new match char B, and var char C equals new match char of C, and var alt for alternate equals new match alternate of a new list which contains char A, char B, and char C. Okay, and then we can exec test on the alternate given this context. Okay. Now, so what we're looking at here is what did I just do? PowerShell interactive, not what I'm trying to do. A or B or C. So this guy right here is that regular expression, right? So what's going to happen is we have a context ABC, and we're going to have char A, char B, char C, and I'm going to try and match it. It's going to say yes. If everything works out, it will advance it that one character, and then we will have something on the stack that says index 0 matched, right? So if I take that and make sure that's what we're going to run, and if we're lucky, it will do that. Match next. Oh, sorry. I forgot that was going to keep doing that. So I don't really care because we haven't gotten a match next yet. But the match succeeded. It advanced to that point, and the stack now contains the digit 0, which means this first alternate matched the first item in its list of tokens, right, which was the char A. So let me stop this. And now let's do something that's going to also crash, but be a little bit different. So now let's make the character start with B. I'll show you the string will start with B. And what we should get is the exact same crash, but this time you see it correctly advance the pointer to the second index, and the stack now contains the digit 1, right? Because that's the one that it matched. Okay, so it appears that this is in fact saving the information that we want, and that's good. So what happens when we match next? Well, we can try doing something different. So when match next is called, I need to start from where I left off. So first thing I got to do is get that piece of information. So let's pop it off the stack, right? So this has physically removed it from that stack on the context. So if I do succeed in matching, I'm going to have to push it on again. But I do want it removed so that if match next ultimately fails, then the stack has been restored to its correct state. And if all of my tokens are written correctly, then the pointer and those kinds of things will also be restored to the correct state. So Well, I've been backtracked into, but I had matched the token at index. So if match list of index, right, my current guy, can do something else, then that would be great, right? So first thing we want to do is take him and try to match next him. And even if, I always think about match char when I think of this, because it's important to remember that at some point this returned true, which means it could have changed the state. And even though what an alternate does, it says, oh, you've been backtracked into, you better move to the next one. That's not precisely what it does. It backtracks into, and only the alternation actually happens to have additional behavior, which gives it its own match next behavior, but you never do that until it's the very last option. Right, so if the token that has already matched at my current index, which is not really relevant at this point, chooses to match next, then I've succeeded in matching, just match something different. So then we just push, stack.push the same index back on, because this is still the one that worked, and we've succeeded, right? If that guy didn't work, then, well, what can I do? Well, if I am not at the end of the list, right, if I have 3 tokens in here, like this guy, ABC, and I match the first one, now that the first one has genuinely failed all of its options, do I as an alternate have an option? Yes, I can try from the next one. So we would then call, and this is where it becomes very nice, match forward on this context from the next index, right? Now, if I'm at 0, right, if this ends up failing, then the stack has already been cleared of my previous match. I will call match forward on the next index, so this will start at index 1. If that is still in range, then we go through our regular matching procedure and try and match. And if so, we push the index to the stack and we're done. If, however, this was the last guy in the list, let's say we matched item 3, which was index 2, then match next comes in here, it pops the 2 off the stack, that fails. We say match forward on index 3, that's outside the list, and that's not an option, so it fails, right? And this buys us what we want. So if we go back to iMatch tests, we can now try, let's see, we have BBC, and I have AB. Well, this should run, for one thing. We can just do that. So BBC matched, right, the stack 1, so index 1 and that guy, and then we tried to match next and it failed, and that's that. So something that is unclear is whether this, just from that printout to the screen sort of, is whether or not this is working correctly. So I could do something very artificial here and say I have a char A, a char B, and then I'll just put char B in there again. So this is this alternation, which is weird, but whatever, right? So in this case, match next should succeed because of alternation. Even though the match here is going to fail, it's going to advance to the third token, and it is another B, which will rematch it, and then we're good to go. So hopefully this is more interesting. So we matched the first time, and we used token at index 1, which is the middle B right here. Then we called match next and ended up succeeding, but you can see that we succeeded by advancing to another item because this stack now contains index 2. Now, then we try something else. It's out of options. That guy failed already, so stack has been cleared. Pointer's been reset back to 0, and everything looks consistent. Okay? So that appears to be alternation. So now what we can do is we can come back up here to the list and see if it is, in fact, doing its backtracking correctly. So if I say, let's create an alternation, right? Something that has the ability to succeed. So first of all I'm doing here is making char A, char B, char C, and the alternates as separate variables, and fixing some syntax errors. So I figured I would speed it up for you guys. Okay. So after a bunch of typing and screwing things up, what I'm really testing in this list is the following. So I have the list A, and then, regular expression looks like A. Parentheses here don't actually mean capturing. We don't have capture groups yet. B or B, and then C. right? So I'm going to try and match against this string ABC. So what should happen, if everything works out correctly, is it will match A, it'll go into the alternation, which will match B in the first index, so we'll push 0 to the stack, and then it will just leave and return to the list. We'll try and match C, that succeeds, and so the whole thing will match. Match next will then get called in our exec test, and C is going to fail. That'll get backtracked into the alternation, which will say, oh, token number 1, do you have options? And he'll say no. That will fail, but then we say alternation, do you have options? And it'll say yeah. And it'll try token 2 at index 1, hopefully that, well, better match. And then C will match again, and then match next is called, and it will get back to here. We've run out of options completely, and the whole thing should fail, right? So that's kind of a nice way. Well, and this also shows that our index is backtracking, our list is backtracking the way that we want it to. So let's do match list test 1. So we matched ABC, and we have a 0 on the stack from the alternate matching the B with the first option. Match next actually succeeded because it backtracked to here, and we tried the alternate and matched it with the B in index 1, and then C succeeded, and then this failed finally because the alternation had no options. The stack was correctly cleared, which is where we started before all this happened, and the index in the matching string has been restored to 0. So that seems to be working, and these are all, I mean, obviously that's not an exhaustive test, but as we build up more tools, it'll be nice to start building really complicated regular expressions, and that's, for me, why I like having this exec test, because I should be able to mentally just step through it and explore all of the options in the same order that it should be exploring them in. And when we get to the tokens like greedy versus lazy, it's that order in which the tokens are tried is easy to debug if you just force it to run through every permutation it can match and look at them to make sure that it's running them, you know, in an order that says this is a greedy behavior, this is a lazy behavior, this is atomic, this is whatever the different thing is, right? And once we have capture groups, that'll become even nicer, because then we can print out, you know, we can wrap things in a capture group and we can say, oh, yeah, this thing matched this piece here, and then it matched this piece the second pass through, and you can look at the stack and watch it kind of evolve over time. And then we'll get into some really interesting cases. So far we can do alternations and repetitions that we can't do. We can't do capture groups, but we can do characters and strings, which is just a list of characters. And we can have alternates, which is like a really cheap way to do character sets if you feel like listing every single thing in the character set. Something else we could do, I guess, while we're here, is this could be, the alternate here could be something different. Well, we'll do that next time because this video is going long. But I was going to say we could flip this around and take a list of multiple characters and embed it inside here, you know, like BB. And so then the alternates would try B first, and then maybe match, and then BB, and then maybe match. Things like that. So we'll do that next time, and we'll start composing them in different ways, and we'll use this exec test to display the complete list of permutations that the sort of a depth-first search goes through, and then I don't know, let's go from there and it'll get better. All right, thanks guys, see you next time.